this video, we are going to talk about triangle congruence theorems. So there are a total of 5 theorems that we'll talk about, and then some false shortcuts that are not theorems that are typically misused as theorems. So again, just to remind you, a theorem is just a mathematical truth that can be proven, and congruence means that they have the same measures, whether that's side measures or angle measures. So the first theorem is side, side, side congruence. So if 3 sides of one triangle are congruent to 3 sides of another triangle, then the 2 triangles are congruent. We have an example here where the first triangle, I'll label it triangle 1, has sides with 1 tick mark, 2 tick marks, and 3 tick marks. And those correspond to triangle 2, where side AB is congruent to side DE, side AC is congruent to side DF, and side CB is congruent to side FE. So a triangle congruence statement could be written for this as if AB is congruent to DE, side AC is congruent to side DF, and side CB is congruent to side FE, then triangle ABC is congruent to triangle DEF. The next theorem is side angle side congruence. Side angle side congruence says that if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the 2 triangles are congruent. Before we move on and show an example, I want to talk about this word included. So we have side AC is congruent to side DE, side AB is congruent to side DF, and the angle between those 2 sides. So our key word here is the included angle. So that means the angle is between those 2 sides that are congruent. So the congruent statement for this example is that if side AB is congruent to side DF, side AC is congruent to side DE, and angle A is congruent to angle D, then triangle ABC is congruent to triangle DFE. Notice the order that I had to write these in. We've talked about this before. But if I have triangle ABC, then I have to write my corresponding letters in that order. If A lines up with D, B lines up with F, and C lines up with E, then I have to make sure that my triangle statement is written in that order. So for these two examples, we have at least two sides that are congruent. So you either have all three sides or you have two sides and the angle between those two sides. Now we're going to look at when you have at least two angles. Starting with angle, side, angle, congruence. For angle, side, angle congruence, if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. So again, I want to point out this word, included. In this example, we have angle A is congruent to angle D, angle B is congruent to angle F, and the side that is between those two angles are congruent. So it can't necessarily just be a side and two angles. It has to be two angles that are congruent and the side that lies between those congruent angles. Our congruent statement for this theorem would be if angle A is congruent to angle D, angle B is congruent to angle F, and side AB is congruent to side DF, then triangle ABC is congruent to triangle DFE. Again, notice the order that those vertices are labeled. The next theorem regarding two angles is angle, angle, side. For this theorem, if two angles and the non-included side of one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the two triangles are congruent. So this one's a little bit different than the last one because of the order that you have the two angles and the sides. So in this one, we have angle A is congruent to angle D, angle B is congruent to angle F, and we have side AC is congruent to side DE. But those sides are not between the two angles. That is okay. So you can have two angles and the sides between them, or you can have two angles and sides that are not between them as long as those sides are corresponding. So notice that side AC corresponds to side DE. This would not be angle, angle, side if, for instance, if we did not have side E. Let's say if this was not marked congruent here, for example. Let's say if this side was marked congruent. If side EF was marked congruent, then side AC and side EF are not corresponding in this case. So it has to be the case that the sides are corresponding. So some key words here are corresponding, non-included side. Okay, the congruent statement for this theorem is if angle A is congruent to angle D, angle B is congruent to angle F, and side AC is congruent to side DE, then triangle ABC is congruent to triangle DFE. The final congruence theorem is hypotenuse leg. So this is a theorem used for a particular type of triangle. So if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of a second right triangle, then the two triangles are congruent. So let's break this down a little bit and talk about what is a hypotenuse and what is a leg. Well, a hypotenuse is the longest side of a right triangle. Now, a right triangle is going to be marked by a little box in a corner that represents 90 degrees. The side across from that is the hypotenuse. A leg is either of the remaining sides of the triangle. So AB is a leg, but so is BC. DE is a leg, and so is EF. So notice that side AB corresponds to side DE. So we have the hypotenuse of these triangles and the corresponding legs are congruent. For this congruent statement, we would have if triangle ABC and triangle DEF are right triangles, and side AC is congruent to side DF, and side AB is congruent to side DE, then triangle ABC is congruent to triangle DEF. Remember when we talked about forming angles and how the middle letter when you're labeling an angle is the angle itself? I just want to point out, if B is in the middle and E is in the middle, those are our right angles. Also notice the order that I listed the last statement in. Triangle ABC, those points correspond with D, E, and F. This is the only congruence theorem that we will talk about for a right triangle. But we do have some false shortcuts. So we've talked about having at least two sides and at least two angles. However, there are two shortcuts that don't always work. The first one is angle, angle, angle. So angle, angle, angle is a shortcut that actually tells you similarity. If there are 3 angles that are congruent between 2 triangles, that actually only proves that one of them has been dilated into the other, or they're proportional, but that doesn't necessarily mean that they are congruent. Next, we have side-side angle. So we have talked about 2 sides and an angle. However, I'll remind you that our congruence theorem is having 2 sides and the angle between them. So the order of this statement tells us that we would have 2 sides and the angle that is not between them. This also works if you're going in the other direction. So instead of SSA, it can be ASS. Either way, that is not a congruence theorem.